T4B, operating controls, tuning, use of filters, squelch, AGC, repeater offset, and memory channels. What may happen if a transmitter is operated with the microphone gain set too high? The output signal might become distorted. You might be pushing the circuits in there too hard and causing distortion to be formed in the circuits beyond the microphone gain if it's set too high. Which of the following can be used to enter the operating frequency on a modern transceiver? Either the keypad, if it has one, or the VFO knob. VFO means variable frequency oscillator, and it's a traditional tuning method for ham or communications transceivers of all kinds, but it's either a keypad or a VFO knob. It can be used to enter the operating frequency. What's the purpose of the squelch control on a transceiver? It's to mute the receiver output noise when no signal is being received. If you did not have the squelch circuit, you would have to listen to that loud hiss from the radio all the time when you weren't receiving a signal. What's a way to enable quick access to a favorite frequency on your transceiver? You store the frequency in a memory channel. And this is especially handy when you're setting up for repeaters because you have the offset frequency and often also a tone that you need to use to access the repeater. So that's all goes into the memory channel. So all you have to do is select the correct memory. Which of the following would reduce ignition interference to a receiver? Turn on the noise blanker. A noise blanker is a circuit in a receiver that reduces pulse type noise, which is what ignition interference would be, a pulse type noise. So turn on the noise blanker. Which of the following controls could be used if the voice pitch of a single sideband signal seems too high or too low? The receiver will have a receiver incremental tuning, RIT, or they're sometimes called a clarifier. The clarifier name is more common on CB radios than on ham radios, but it's the same circuit. So RIT or a clarifier can adjust the pitch of the voice on a received signal. What does the term RIT mean? It means receiver incremental tuning. What that means is you can change the frequency, you can change the tuning of the receiver slightly without changing the tuning of the transmitter. What's the advantage of having multiple receive bandwidth choices on a multi-mode transceiver? The answer is it permits noise or interference reduction by selecting a bandwidth matching the mode. And I found this graphic today also. Here we're taking a look at a spectrum, a piece of the radio frequency spectrum. The frequency is going higher as we move this direction. Here is the signal that we want to hear. You're always going to have some noise. So speaking of some noise, you're always going to have some noise, and you can reduce the amount of noise that's getting in your receiver by reducing the bandwidth for your signal. So if I have this bandwidth going to receive this signal, I'm going to have all of this noise over here coming in as well as the little bit that is associated in the same frequency range as the signal. The other thing that can happen if I'm using a broader bandwidth than I need, there might be another signal over here that I don't want, but it will still be coming into my receiver. So by adjusting the bandwidth to match the mode, I'm able to reduce the noise with the interference. Which of the following is an appropriate receive filter to select in order to minimize noise and interference for single sideband reception? 2400 hertz is the appropriate filter width for single sideband voice. 2400 hertz. Which of the following is an appropriate receive filter to select in order to minimize noise and interference for CW? You'll remember this means Morse code reception, and that's 500 hertz. So you can see much narrower than the 2400 for voice, the 500 hertz for the on and off keying of the Morse code. Which of the following describes the common meaning of the term repeater offset? This is about the third time we've had this question in some form or other. It's the difference between the repeater's transmit and receive frequency. And you'll remember from last week we spent some more time on that when we talked about repeaters. Whoa, we're here already. Okay.